Alright, should be another draft physics video presentation. Some more two-slit information. A couple of commenters have brought up, again, the goalpost changing. So I gave them a simple task, right? I'm basically arguing, they're saying that it's a wave phenomenon. It's traditionally drawn like this. Two waves come out, two waves overlap, two waves create an interference pattern. It's all over the place in the college lectures, everywhere. This is the thing used, okay? So let's not play any games here, people. Commenters. Either concede this image is wrong, incorrect, it doesn't happen that way. Okay, you can't change the math and say, no, I have math that's different than this. Because it has to be different than this. This math is really simple. The geometry is really simple about where these intersections take place. All right, where the waves intersect. Those lines are clear mathematics, can be easily drawn. So don't play this game with me, right? You're saying it's a wave. You can't show me a formula that says it's a wave. It's a pretty simple thing to draw, like I said. Draw your waves. See, what you need is 4 sources. So you need to create 4 waves. Unfortunately, if you put them here, it won't work. Because the real thing that's causing the effect is this distance. This distance and this distance. And guess what? Your waves aren't in the right place. They're over here, and they're in the wrong places. They won't create the right geometry. Because these are the points where the right geometry actually is. This is the one distance. This is the other distance. These are the surfaces that are creating the phenomenon as I stated. It will work if you use those 4 locations. It will not work with yours. So draw it as a wave or concede it's not a wave. Okay, so let's go to the Google page. Again, don't play this liar game with me, please. All right, like we don't know what the traditional drawing is. 2 waves. Okay, every one of these will be 2 waves. You can't see that image. 2 waves. 2 waves. Okay, 2 waves, clearly. 2 waves, clearly. All right, so don't play this game that, oh no, physics has the right answer. Single slit. 2 waves, ironically. Hilariously. Okay? 2 waves. Alright, so don't keep saying, oh no, they do explain it. They do explain it. They don't explain it. And you can't do it as a concept. As a wave concept, you can't draw the picture as waves. And it's, again, not demanding much from you. If you have to add some waves, well, go ahead and add some waves. What you might have to add 2 more waves somewhere? Go ahead and add your 2 waves somewhere. It still won't work. The geometry won't work. And that's the simple truth. It won't create the dead spot where you need it. It won't create this dead spot in the 2 slit. You can't do it from these locations. So you're done, you're cooked, you're doomed. Your theory isn't correct. All right, so I guess I'll read some more and then get to the point. But that was your task, is to draw a picture. There's only 2 slits. It can't be that difficult for you to draw a picture of your wave interference. Show me where 2 waves are interfering to create the pattern. Don't show me, oh, I have math. No. Draw me a picture. Ugh, it's pathetic. All right. I couldn't find a video using the double slit you use for the double slit, single slit. Well, it doesn't matter. Again, you don't get the argument. This pattern, the pattern right below me, is not in dispute. I'm not disputing the existence of the frickin' pattern. That's why I showed the frickin' pattern. I shouldn't get angry. But I mean, you don't see how you're just evading the subject by pointing out that somehow the pattern is the subject? It's not the subject. We all agree on the pattern. Oh, amazing. All right. So I opted for a similar one where the slit width separation of slits is given. Who cares what the separation is? As pointed out, we already know what affects the pattern. If the slit is narrow, the pattern is big. Okay? The blocks are big, the spaces are big. If the slit is wide, the pattern is small. The bricks are small, the separation is small. All right? So we already know that. That's the only factor that means anything, that has any relevance. That's it. The width is everything. The distance between the surfaces is the definition. Okay, and you can call it D, or you can call it A. You can play your little change the variable name games all you want, but that's the simple truth. There's nothing else needs to be known, really. That's all there is. Okay, he does the test with a 0.4 millimeter slit. Who cares? Separated at D1 by 0.25. So he's not using ones that have symmetry, right? So the simple argument is, see, he's going to show diffraction gradient math. Okay, and obviously a diffraction gradient has very consistent slits. Okay, so a diffraction gradient uses lines, and the lines are all the same distance apart. The gaps are all the same distance, so it's all symmetry all the way through. So obviously this pattern below me is made of perfect symmetry. The double slit has exactly the same dimensions as the single slit above. So the single slit opening is exactly the same width as the impediment, and the distance here is exactly the same as the distance from here to here. All these distances are exactly the same distance. D equals D. Okay, all of them are D, 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 and D. And as you can see, the two patterns fall right on top of each other. A single slit with opening D will create a pattern that overlaps the double slit where D, D, and D is being used. All right, if I use a wavelength of 500 nanometer light, it doesn't matter. The light will just change where the bars are. It won't change anything else. Okay, so doesn't matter. Obviously, to do the geometry of the cast, where all of the photons are scattered. So all the photons, red ones, blue ones, green ones, they all do this. They all diverge, or you could say diffract if you want to, but they all do this. They all go to all locations. The red light hits all locations, and it's only in certain locations where you reconstruct the photons at the same phase, the lines equal line length, therefore, wavelength consistent, and therefore you'll see a photon there. There's still energy hitting here, but there's not enough to create a photon. They're not in phase. Same amount of energy is here, that's here. This is out of phase, this is in phase. In phase remakes a photon, out of phase doesn't. That's all that's happening. So different colored light just lines up in a different location. It's been often showed. The blue light will be first, and then the red light will be second, and then there'll be another blue, and then the red and the blue will be on top of each other, and so on and so forth. Those aren't facts in dispute. I mean, I guess the idea that you think when the red photon goes in, it bends a specific place to hit a red spot. No, it goes to all the locations. You just reconstruct the photons in one location. All right. We get this. All right, green light. Then we get this. So we'll go to this link. I don't think this is anything terribly important. So obviously I would disagree with some of these intensity arguments. I don't think they've ever tested it. I don't think there's 90 whatever % of the light going to the center and the rest of these little tiny humps. They're brighter than that. But I'm not going to, it doesn't matter to me. If you want to believe that tower, go ahead. It doesn't matter. All right, but this is in dispute. Again, the pattern is not in dispute. Okay, you can keep playing this game like the pattern's in dispute. No, the pattern's not in dispute. All right. So as again, both seem like pretty accurate representations. irrelevant. If you give me the slit width and the separation between the slits, it's completely arbitrary. Just make up any ones you want to. I don't care. It really doesn't matter, as we know from the diffraction gradient. I can put 500 lines in per inch. I can put 1,000. I can put 700. I can put 68. Doesn't matter. They can all have different, they'll all have the same, as long as there's some symmetry, the same widths of the slits. Obviously, if you use two different shaped size slits, you're going to get a pretty bizarre pattern. So anyway, I can generate a testable pattern you want using the two-slit equation found in. So he calls this the two-slit equation. Now, it's not the equation they use at MIT or Stanford or Yale or any of the universities for that matter. It certainly can't be drawn as a wave. So why are you calling it the wave math? Because it's not wave math. You can't draw it as a wave. So draw your math as a wave, and then I might believe it's wave math. But the fact is you can't, even with just two slits. Even with just two slits, you can't use that math and draw the waves. You don't see that that is a critical error on your part? That makes this whole conversation pretty much a fraud? So let's look at the page. So somebody else brought up this convoluted math before. And again, it has to do with multiple slits. This is obviously a diffraction gradient. The math works for a diffraction gradient. Okay, and then they're trying to apply it to the two-slit, which is stretching it a bit. Okay, but there's no waves drawn here at all. We don't see any waves. Okay, we see sources. All right, and you can really see it later on. So, they're using a more complex equation because you have to account for the fact that there's two patterns superimposed on each other. And I'll show you basically all this crap, right? The integrals, all of this complex math to do this. Look at all this math. Nothing like the two-slit math used at MIT, right? More complex math, blah, 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 blah. And, here you have a drawing of it, right? The waves come in, they go through the slit. They're drawing 3 different lines here from each source. What is that? So they have 5 sources, and they end up with 3 locations, and so each location has 5 lines going to the 5 sources. What are all those lines representing? That's not a wave. Obviously, there's no wave in that drawing, is there? No, there isn't. So obviously, it's not a wave theory. So you can keep saying it's a wave theory, but it's not. This is really the giveaway. Because when they draw the two-slit here, obviously they're just drawing the two-slit in the traditional sense of a bunch of little bars going across the screen. They're not drawing it with the gap that happens. And then they say 3 slits makes this pattern, and 4 slits. And what you're really getting is the harmonics of a frequency. So what all of this math is really doing, I would argue. Okay, I'll show you. See, no waves here shown at all. No waves anywhere to be seen in this entire page, not a drawing of a wave on the page anywhere. So it's obviously not a wave equation, it's a geometry equation. And I'll show you how simple the geometry is. It's startlingly simple what's really happening. And so if somebody has some computer wherewithal, simulation wherewithal, or even just what you need is an image you can zoom into, because what really is happening, okay, is you're really just stacking, okay, all of the possible positions that something could be in. So if I was to draw it as just 2 slits, I would have, I would say, okay, the first pattern is the bottom pattern here, right? So that's the single slit pattern. So you could just draw that as a hump, and then a big hump here. I should do it on the screen, right? So let's use this as the middle one. And then we have a little smaller one here and a smaller one over here, just to abbreviate it. So that would be the single slit pattern. And what we're saying is if we use the same geometry, for the double slit, that we can get these little bars to line up right underneath these. So the simple point would be to make is that these little bars really do go all the way across. All right. And through the whole thing. And that's all you're really doing is just stacking 2 patterns on top of each other. And the fact is, this one would be invisible without these contributions, And this one would be invisible without these contributions. So obviously, if I was to draw that better, that one's missing, and this one's missing. I'll just knock out 2. It doesn't really matter. I'll just put this little one back and put a little one back here. And because this one really is here, this little block was here, but it's too weak. So it ends up being a dark spot. So clearly my theory explains it in the sense that that's all there really is. Now, if you were to do a multi-slit, what you're really doing is stacking those patterns on top of each other, and you could sort of understand it as, you know, you start off with the 2 furthest slits. So if I have numerous slits, yeah, you can't see that. So if I start off with numerous slits, right, you could say, okay, what geometry do these 2 create? All right, so we know that's a very wide slit, right? So that would be very small bars. So I could just draw that as this, you know, like the. So this, you need to make this like 1,000 across, or maybe 2,000. So you just have an even little square wave going up for 1,000 of them go across the screen. So that would be the 2 widest slits. Well, let's do these 2 now. So what's the geometry for them? Well, that's going to mean bigger blocks. So the blocks will be 1.5 the size of these blocks. So 1.5, and then dead for 1.5, and then up for 1.5, and then dead. It's actually 2 blocks. So you're just doubling the block size. Okay, so let's just do that, and you'll see what I'm getting to here. But this is all their math is doing. Their math is simulating this process. So you can mechanically, all mathematical formulas should be able to be illustrated. You know, the mechanics, because they're all basically geometry. And that's all there is. Oh, I didn't want to erase that. My mistake. All right, so we did these 2 outside ones. We did these 2. Now we're going to do these 2. Okay, so same process. I start with the middle, and I go 1.5, you know, twice as big, and then flat, and then up, and then flat, and then down. All right, so you should be starting to see what the math is doing. Okay, so let's go to the next step, the next bunch. So that would be here. So I'd end up with a pattern here, and then I go down, all the way to here, and then go back up. So you can see I run out of room to draw it pretty quickly. That's why you need like a scalable image, or, you know, I don't know exactly how to illustrate it without making a very tedious image file. But anyway, you can sort of see what's happening. There's this location where they all stack, one on top of another, on top of another, on top of another. And if you added it up, there would be, these location would be a little bit more stacked, and then this location is a little more stacked, a little less, I mean, and a little less, and a little less, and it basically is going to create a cone, and that is essentially what they draw the other way, which is a peak. And then it goes blah, 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 and then it peaks, and then it goes blah, 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 blah. And these are just harmonics. So where you get these circles in space with the multi-slit, that is with a diffraction gradient, you get these circles. And the circles will be, this pyramid will repeat like 200 or 300 of these little bits away. It'll repeat again. The same pyramid will be formed. Because what you're really doing is just creating another one of these double hump things, right? This exact shape, okay, will be formed again. And, you know, once I make this last one. So once I make the last one, so I'm going to go through hundreds of these, you know, 100 of these radiations. There might be 200 lines that are actually in the beam of the laser. So it could be actually 200 of these things. So obviously I have to go 200 levels up. But you can see that when I do the last one, it's a 50-50 thing, and the very next hump will be another pyramid. But the difference, the length, the distance of the slits is an incredible distance, because this is incredibly narrow. These little lines are so close to each other that the width of the clump, you know, the single slit pattern, the width of this, okay, becomes thousands of these. thousands of them. So thousands of little bumps fit inside of one of these clumps. So you can understand when the second clump shows up, the same thing's going to happen. You're going to get another pyramid. Another one of these pyramids will be formed, where you have on top of on, 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 on top of on. And so those are the places where the most broken photons are going, and obviously the most photons will be remade. And there'll be very little photons through all these other locations where they're all on. So they won't be making photons as many. And then you'll have a big on again. And that's the story of it. That's what the math is really doing. So, anyways, it's like I said, they're just changing the subject. So, look, it's fine. If you want to say this web page is doing the math correctly, that's okay, as long as you admit that the way they teach it, the way the professional talking heads talk about it, the way they illustrate it is completely incorrect. Because you can't draw this as a wave. You can't make your slits do this geometry correctly as waves. You have to put these things in different positions. Because the fact is, the point source is the surfaces. The point source isn't the middle of the opening. The point sources is the edges of the slit. And that's what you're getting wrong. And so it's all consistent with my theory. My theory works, and it's honest. It's not drawing it as waves because it has nothing to do with waves. It has to do with vectors. That's why this page draws it as vectors, because that's what it has to do with. It has to do with vectors. All right, it's geometry. It's not waves. All right, so that's probably enough. I don't think he said anything else of significance. Let's just finish up. Okay, testable pattern using the two-slit explanation equation found here. So again, you won't concede though. You won't concede that that's not how they teach it. This isn't what they teach because they can't draw that because it doesn't work. Okay. Anyway, where I picked a random value for the intensity IQ, the equation is derived using electromagnetic waves. No, it isn't. It's not. So you can say it's derived through, no, it's derived through sine theta. Until you prove sine theta is a wave, it doesn't have to be a wave at all. It can just be an angle at which a ray of light goes. And as I'm pointing out, the rays go everywhere. And it's just the only place you can reconstruct a photon. If I'm right, it is logically the only place you can reconstruct a photon. But it won't be the place your waves interfere. So you can't draw it as a wave. The equation is using electromagnetic waves. So again, it's not drawn that way. You can't illustrate it that way. So there's no way for you to demonstrate a wave is doing it. And I'm just asking you to do it with two slits. I'm not asking you to do it with a diffraction gradient where you have to draw 2,000 waves or 4,000. No, I'm just asking for you to do two openings. Show how two openings creating two waves can create the pattern. And until you do that, you have no right to call it a wave. All right. Hopefully this makes the wave model more believable to you. So again, it's not a wave model. There's only two waves involved, and you can't draw it. The wave model doesn't create the double pattern. It doesn't happen in water. It doesn't happen in a pond. It doesn't happen anywhere. It's a light phenomenon, and it's not waves. Okay. Edit. I claim that the amount of maxima is slightly inaccurate, but you can actually see the correct number if you zoom in pretty deep into the intensity graph. Well, whatever. I'm saying they never measured that, so I'm saying it's horseshit anyway, but whatever. However, you might get a better representation if you use D1 equals 27 millimeters. Again, the size is just telling me how far away the surfaces are. So it's just telling you what the harmonic's going to be. You're just deciding the frequency of something, and you're just basically saying, well, the length is going to decide what the harmonics are. So that's all you're doing. Doesn't mean anything. Again, that's not the part in dispute. Anyway, slits. In the first case and 52 millimeter in the second case, the breadth of the hair can change the results significantly. Yes, that's why a diffraction gradient works. You know, it's because literally there's 200 lines in the beam of the laser, you know, 200 or more. And that the furthest ones are hundreds of times further apart in geometry in space than the two closest lines in the middle. Those two are hundreds of times closer to each other than the two very furthest surfaces. And that's all it's really about, is the distance between the surfaces. All right. The breadth of a hair can change the results significantly, but the accuracy is good enough. Well, you say it's good enough. Then that's your claim. And I'm saying it's not even close to good enough, and you're lying to call it waves, because it's not. But you can't draw it as a wave. So it's not wave interference. There's no waves interfering. There's vectors that collide in the same location. And that's all that matters at the same phase. All you're doing is finding lines that are a full wavelength, longer or shorter. And those lines are meeting in certain locations that are full wavelengths, longer or shorter. And there's only certain places they'll land more often, coming from more sources. And that's it. So, if you were an honest person, you'd concede my theory does explain it. If you were honest, you'd concede my theory explains it with much simpler mechanism. You know, really simple. And you'd quit playing this game like, you know, they've proven something. That they put any nails in any coffin, you know, 100 years ago when they decided to do this silly wave physics. They never put those nails in any coffin. All right. So again, if you can't draw a picture of a two-wave system, then I would say that's evidence your physics is shit. All you're required to do is a system that isn't any more complicated than just two waves. Draw the two waves and show how wave interference makes the pattern. And if you're going to draw four waves, then explain why there's four. And if you're going to draw four waves in the wrong location, then explain how the hell they got in the wrong place. Because that's the only way you're going to be able to do it. You're going to have to put your waves in the middle of the impediment. Somehow the wave went through the impediment. Because it won't work with your traditional two-wave hump thingy. It ain't going to work. And you know it. And you should just admit it. It doesn't work. The traditional math doesn't account for the real pattern. And if I go to Google, I could spend all day going through those images, and I'll never find a wave drawing that is accurate, that actually accounts for the double slit pattern. These two waves do not do it, and you know it. So why don't you call all of this what it is? Inaccurate, propaganda, bullshit. Because that's what it is. It's inaccurate, it's wrong, it's not the truth, it doesn't work, it's not a good enough answer. Young's double slit problems. Yeah, I'm sure, you know, they're just doing the problems instead of recognizing it has a big giant problem. It doesn't work. Okay. Yeah, I don't know. There's nothing, like I said, you just want to cheat. You want to have it both ways. You want to say it's a wave, and yet you're not willing to draw it as a wave. And that's pretty lame. Waves are pretty simple. Why can't you just draw it as a wave and show me how two waves interfere with each other and create those gaps? Because you can't do it. Alright, that's all. That's enough. This is just such bullshit. You know, let's just move the goalposts. Let's run away. It's time for you to run away, right? Just run away. Yeah. Alright. Such bullshit.